Alright, welcome back to AP Environmental Science, Chapter 7, Part 2. We're going to start off with reproductive strategies and population fluctuations. The two type of ways that we can broadly lump organisms into for how they reproduce are K strategists and R strategists. K strategists are large organisms that live a very long time. They produce very few organisms. They tend to provide a ridiculous amount of parental care, and populations typically are stabilized at carrying capacity. So again, carrying capacity, oops, did that again, sorry about that. Carrying capacity on this scale would be here. So populations typically stabilize at that point, and reproductive strategies to invest in a few high-quality offspring. Here's a little bit more on the K strategists. They're typically limited by density-dependent populations. So those are usually biotic factors. So remember, biotic factors are living factors. So factors that can become more severe as populations grow in size. So size of population, competition, available food, and disease. A few examples of these K strategists are deer, lions, humans, whales, and sharks. On the other side, we have the R strategists, and these typically are smaller organisms that live a very short amount of time. They produce many offspring, and they provide very little parental care. So they usually do not reach carrying capacity. It's a boom-bust cycle, so a lot of them and then none of them, or limited of them. A lot of them, a limited of them. The reproductive strategy is basically to produce a large number of organisms and with the understanding that most of them will die. Our strategists are density independent, so we're looking at weather factors as the big cause of controlling a population. And a few examples of these are grasshoppers, gypsy moths, mice, and zebra mussels as well. Here we have the survivorship curves, and there are three types. So basically on survivorship 1, we have that a number of the survivors is pretty high over the maximum lifespan, and then it starts to drop. Where you compare that to survivorship 3, where lots of them die before their maximum lifespan, and then very few actually live out the whole time. And then you compare that to survivorship 2, which is consistently, organisms are dying consistently over time. One reason for human population growth is the increase in medical care, and as a result, a decrease in death rates. So the reason we're seeing this part right here of our human population growth is that our death rates have gone down, and that's because of medical care. Here's another one of those equations you need to know for the exam as well as our test. It's doubling time. You might be asking, how do you get this 70? Well, that's a constant. So we take the constant and divide it by the population growth rate, which is what we figured out earlier, and we get how many years it will take for the population to double. So 70 divided by 2% is 35 years. So if we're at population X, to get to population 2X, it's going to take 35 years. Here's a human population curve, and as you can see, we have not reached our carrying capacity. Some people think as little as 11 billion will be there, and others say as many as 14 billion. We are at 7.3 billion people on this planet, and if you look down here, just 214 years ago, we only had 1 billion people on the planet. So we're using more resources now just by the number of people that are on the planet. Here we have the demographic transition model, and this is a famous graph that you need to be familiar with. It has 4 stages, so pre-industrial, transitional, industrial, and post-industrial. In pre-industrial, you're going to have a high number of birth rates as well as a pretty consistent high death rate, resulting in a pretty low population. So this green line here is the relative population size. In the transitional model, you're going to see our birth rates go up a little bit, but pretty much stay the same, but our death rates are going to go way, way, way down, and that's going to be because of medicine being introduced, and therefore people are able to live and then the population's going to explode. After that, and that's what you see here in this green line, after that you're going to have the industrial stage, and here we're hopefully reaching the carrying capacity, and our death rates and birth rates are leveling out, and our population is leveling out into that carrying capacity range. Unfortunately, the next phase, the post-industrial phase, is when birth rates fall below zero growth. So fall below that magical 2 number, and instead you'll get 1.1 or 1.8 or any number below 2. And that's going to result in negative growth, and your population's going to decrease. Here's another graph of that human doubling time. Again, at that 1%, you see 70. There it is. There's that constant. At 2%, we have 35 years for the doubling time. If we have a 4% growth, it's going to double in 18 years. So that's how you read this graph. So there are factors that influence human population, and this can be social factors. So these humans are social animals and have the freedom of choice. So here are some reasons why decisions are based upon social, ethical, religious beliefs, political, economic, for why people choose to have children or not. So one suggestion under social factors is to reduce the fertility rate in our developing countries, or what used to be called third world countries. Not everyone agrees with this. As you've seen in the movies, that for every 1 child born in the U.S., its impact on the planet is actually equal to 30 children born in India, just by the amount of resources we use. So not everyone agrees with that statement. Other social factors determining family size is the role of women in society. If it's a male-dominated culture, the traditional woman is to marry and raise children and doesn't really have a right in that. Lack of education opportunities is another reason for women that is a social factor. Early marriages, and which results in a high fertility rate, is another reason. But there's a correlation between the amount of education and fertility rates. So when education increases, fertility rates drop. Again, in the social factors, some cultures desire large families, so there's a high infant mortality rate. And then young children can bring in income. In an underdeveloped world, children are an economic gain. So this is something to think about. There are also political factors. So governments can either reward or punish high fertility rates. So in China, there's an emphasis to have 1 child, where in several European countries, they're concerned about low birth rates, so policies are in place to encourage to have children. Also, in the political factors, most developing countries are concerned that population growth is too rapid. So there's populations to control this. So family planning, age of first marriage, and 1-child policies. Finally, in the political realm, there's the immigration policies, which are developed. Countries are under intense pressure to accept immigrants. And then this pressure to accept them results in strains on that country's resources as well.